There is a small change formula for when you've got a function of two variables. Now, if you recall that when you've just got y as a function of x, then you know that a small increment of y over a small increment of x is approximately equal to dy dx. You know that's if the change in x is small, then that's approximately equal to dy dx. Now, if we multiply both sides by delta x, we can say that delta y, the small change in y, or the change in y, will be approximately equal to dy dx times delta x. So given that you change x by a small amount, you can calculate dy dx and say calculate the small change in y. Now, another way of writing that, even though I've written delta y and delta x here, if y is a function of x, another way to say this is that the small change in f will be approximately equal to df dx times delta x. So y and function of x are interchangeable, so the small change in the value of the function is equal to df dx times delta x. So that's when we've got y as a function of x. What happens when we've got z as a function of x and y? Well, the small change rule or formula goes a little bit like this, that the change in the function will be equal to the partial derivative of the function with respect to x times delta x plus the partial derivative of the function with respect to y times delta y. So that's the small change formula. So given a small change in x and a small change of y, this should be approximately equal to, the closer you get the smaller the values of the small changes in x and y, the more that becomes an equal sign, but it's approximately equal to. So the change in the overall value of the function can be calculated by finding partial derivatives with respect to x and y, and then using the small change in x and y. So let's just look at an example. So if you've got f of xy is equal to 5 plus x squared plus 3xy plus y cubed, and we're asked to find the small change in the function at x equals 1, y equals 2. Okay, so we've got partial derivative of the function with respect to x. Y will be a constant, so that'll be 0, 2x. Now if y is a constant, it'll be 3y times x. Derivative of x is equal to 1, so it'll be just plus 3y. And the derivative, if y is constant, derivative of that will be equal to 0. And the partial derivative of the function with respect to y, now so making x constant, so that'll be derivative of that 0, derivative of that 0, and if x is constant, then that'll be just equal to 3x, the derivative of that, and derivative of that will be plus 3y squared. So therefore we can say that the partial using the small change rule or formula, the change in the overall function will be equal to partial derivative with respect to x, so that's this here, 2x plus 3y times delta x plus partial derivative of f with respect to y, which is equal to 3x plus 3y squared times a small change in y. Now, we're told that x is equal to 1, y equals 2. So the small change will be equal to, if you put x equals 1, y equals 2, you get 2 plus 6. 2 plus 6 will be 8 delta x, plus x equals 1, so that'll be 3 plus 12, which will be equal to 15. Small change in y. So at this point here, when x equals 1 and y equals 2, any change in the function can be approximately calculated by doing 8 times the small change in x plus 15 times the small change in y. As I said, the closer these are to 0, so the smaller these values are, the closer the approximation becomes. Now that may be handy in doing calculations. You can actually go through, and it's in your notes, to see that if you make delta x and delta y too big, the approximation is not worth it, and it's nowhere near exact enough. So these two values here have to be close to 0 for the approximation to be true.